Well, good day, everybody. How you doing? This is Chris with the Ancient Scholar. What I wanted to do today is I wanted to do a video talking about something in the news. And this is of toxicological importance, and this is something known as street names. It goes by the street name of Flakka is the common name that I see or hear. Flakka, and I believe there are some other terms such as gravel, dirt, those kinds of terms, because apparently it has a kind of a flaky, dirty white appearance. So we're seeing lots of reports of people, particularly people in Florida, which is where I just recently completed graduate school in kind of central to northern Florida, University of Florida, studying pharmacology. So my alma mater there. And apparently this seems to be more southern Florida, so I'm going to assume, Orlando, Miami, those types of areas. People are dying and overdosing and having all sorts of problems, and the signs and symptoms appear to be very similar to agents that we all know and love. And so we're seeing people that are coming in, they're very agitated, they're tachycardic, they're euphoric, they're having lots of behavioral issues, they're very aggressive, they're having hypertension, tachyarrhythmias or tachydysrhythmias, and they're having cardiac arrest and myocardial damage and neurological problems and et cetera, et cetera, et cetera. And at the end of the day, just like when we talked about bath salts, which this is intimately related to bath salts, if there is some new drug out there that is getting people really excited, it looks like a sympathomimetic toxidrome, okay? If it's a sympathomimetic toxidrome and people are going nutso on it, rest assured it's probably some sort of amphetamine. That's the moral of the story. And in fact, that's where our story is going to start. So I'll just rehash the basic amphetamine structure. So boom, there you go. There's your basic amphetamine. All right, you've got your aromatic ring, right? You've got your NH2, right? So I've got my amine, and I just happen to have a methyl group hanging off the side here. So lots of pi carbons here, methyl group here, pretty nonpolar, really good at getting into the brain, really good at acting a whole lot like dopamine, norepinephrine, epinephrine, and that's where you get your nice excitatory effects. So there's your amphetamine. Okay, so this whole Flakka craze, I think what I'll do is it actually belongs to a category of molecules that can be loosely we can loosely call them the cathinones, the cathinone-like molecules. And I've talked about cathinone in some detail already. There's a plant called khat, which comes from Africa, and I believe maybe the Arabian Peninsula as well, mainly Africa, I think. Khat, and they chew on the leaves and they get a little psychostimulatory effects. Not a huge deal, but hey, guess what? The active component of that is something known as cathinone. Some people call this beta ketoamphetamine. Some people call this benzolethamine or benzolethamine. Yeah, that sounds good to me. I'll call it beta ketoamphetamine because if you look at it, you have your amphetamine here, and then you have your khat molecule here, and what do you notice? It looks a hell of a lot like an amphetamine molecule, doesn't it? Right? I don't have enough carbons to make a pretty amphetamine molecule for you guys. Sorry. So let's compare these two here. What's really the only difference? Well, the only difference between cathinone and amphetamine is the fact that this carbon here is modified a little bit. You guessed it, I have a ketone there. That's the big difference, right? Big difference between cathinone and a proper amphetamine is this carbon right here has a double bond in oxygen, so that's a ketone. That's the difference. And that's why we call it beta ketoamphetamine. So it's just an amphetamine that has a ketone modification. So As you might guess, this is going to have a lot of amphetamine-like effects, and that's what we see with khat, right? And then with cathinone, okay, the active component of khat, we see a sympathomimetic toxidrome, a very amphetamine-like effects. And then we modify this a little bit, and we can get things like mephedrone, which we see in bath salts, right? Well, it is this general category of molecules where this whole Flakka or this gravel substance falls into. And the chemical name for Flakka is alpha pyrrolidinylpenthiophenone or something like that. Look at that. I spent years studying pharmacology and I can't even pronounce half of the names of these things. Yeah, I believe it's alpha pyrrolidinylpenthiophenone. Yeah, there you go. Alpha pyrrolidinylpenthiophenone. Sounds good to me. We'll just call it, we'll just call it Flakka. How does that sound? Now, Flakka is actually a direct modification of another molecule, a cathinone-like molecule, and this molecule is something known as MDPV. All right, and I'll just throw that MDPV up for you guys here. Bam. Yeah. Let's see if I can get this. There we go. All right. Okay, cool. So MDEPV, and MDPV is, get ready for it, methylene medioxypyrovalerone. Methylene nedioxypyrovalerone, MDPV, and this was actually a sort of a derivative of cathinone. It's actually completely synthetic, and this is actually designed in the 1960s, I believe. And it was originally designed, so it's completely synthetic. It was really originally designed to be like an appetite suppressant, and we found out that it had pretty pronounced psychostimulant effects. And this is actually one of the substances found in bath salts as well. So bath salts are just a kind of a hodgepodge of synthetic chemical amphetamine-like substances. MDPV just happens to be one of the primary ones, and so they found out that, hey, what do you know, it has lots of side effects and we can't really use it therapeutically, and so it wasn't used therapeutically, but we do see it used recreationally. And as you might guess, it has a lot of amphetamine-like side effects. I think it has a half-life of a few hours. Euphoria, just all the amphetamine-like stuff you've come to know and love. The difference between this and some of your amphetamines is this actually has, and a lot of your amphetamines have this as well, but this has norepinephrine and dopamine reuptake blocking effects. So it blocks the reuptake of those neurotransmitters, and so those neurotransmitters stay out in the synapse longer and activate their postsynaptic receptors longer. And of course, this is the whole pleasure, the whole dopamine pathways. So as you might guess, you can get, these are pretty addictive and can cause dependency fairly easily. Okay, so that is this MDPV here. But how do I go from that to this Flakka here? Well, it's a real simple modification. So if I just zoom in here, I want you guys to take a look at this right here, this structure right here, this little ring-like structure. This is called a dioxylane ring. Okay, so it's just a heterocyclic ring. It means it has more than one type of atom. Unlike an aromatic ring, which has only carbons and obviously hydrogens, but we're not really even talking about the hydrogens. Hydrogens aren't even here. But if I just remove this ring here, okay, this dioxylane ring, all right, there we go. I remove that, and I have this molecule that's left over here, okay. This is in fact, well, not quite, almost, but not quite. So I removed that ring there, and then I have my carbon here. And remember how I said that the Flakka is kind of an MDPV or a cathinone-like molecule. Well, all I need to do, and I just don't have enough atoms to do it, I'm kind of lazy, but all I need to do is I need to take a ketone, a double bond to an oxygen, pop it right there. So just imagine, use your imagination. I've got a ketone group here, and boom, right? So I remove the ring, add a ketone group, and now I have my Flakka or gravel or dirt or mud or whatever the kids are calling it these days. So it is very similar to MDPV. I would assume that it's going to have very similar effects, and that's what all the news reports. It's not a robustly studied substance because, again, this goes back to the 60s when we developed these. There's so many side effects that we just didn't really develop them any further. But it's very similar to MDPV. It has norepinephrine, dopamine reuptake effects, as well as, I believe, some direct dopamine and norepinephrine effects. So it's going to be very similar to amphetamines. It's pretty potent. I would expect it to have a similar half-life, 3, maybe 4 hours, or a few hours, just like MDPV. I believe NDPV undergoes, phase 1 biotransformation is probably going to be the COMT or catechol-methyl transferase, as a lot of your amphetamines and amphetamine-like molecules are going to undergo COMT, and then from there, probably glucuronidation or something like that, whatever the metabolites are. The metabolites after COMT catalysis can be measured and quantified, so you can detect this in the blood. I don't know that these substances would necessarily pop on a urine drug screen under amphetamines. They very likely could, but I know some of the substitute amphetamines don't pop. So I would not use a urine drug screen to guide therapy. Really, a urine drug screen's pretty useless in the emergency clinical setting, and that's just my humble opinion. It's really going to be what the clinical presentation is, and that you'll use that to really guide you into a sympathomimetic toxidrome, and then from there it's just going to be really good supportive care. Benzodiazepines are probably going to be helpful, like they are with a lot of your other amphetamines and amphetamine-ish substances, and good supportive care, possibly active cooling. Might need to give fluid boluses. If it's really robust stuff going on, you got to worry about rhabdomyolysis and all that nastiness there. But yeah, I think good supportive care, benzos, cardiac work up their electrolytes, rule out H's and T's and all that stuff, and then get them tucked away in the unit. And hopefully they don't, die of a cardiac dysrhythmia or, some sort of sympathomimetic problem. So that's Flakka. Honestly, I expect in the coming years to see a whole bunch of this stuff. So I know I sound sort of apathetic about it maybe, but it doesn't really surprise me, and I kind of want to just make a sign that says, relax. It's just another amphetamine, and that's basically all we're dealing with is just another modified amphetamine-like molecule that has amphetamine-like side effects, and those street chemists are doing the best they can to stay a step ahead of the legislation by, in some cases, and just providing some new and novel substances that pretty much do the same thing as the old substances do in the market. So that's my take on this whole Flakka craze. There's nothing particularly special about it. Yeah, obviously it's potent and has lots of effects, sympathetic effects, and norepinephrine and dopamine uptake blocking effects, but this is nothing particularly new or special. We've seen this, so we know what's going on. So there you go. Hopefully you guys found this video informative and helpful, and as always, thanks for hanging in there, guys.